Want to understand the intricacies of AI model? So let's dive into the world of prompt engineering and learn how the context window and temperature parameters shape your results. So what is context window? Basically, this context window is a setting that controls how much surrounding information the AI model consider when generating a response. So it allows you to fine-tune the model's understanding of context in the input text, resulting in more accurate and relevant outputs. So to understand this better, imagine you are a message repeater at a party. You hear a sentence and your task is to repeat it to the next person. Now the context window is like number of people you are allowed to pass the message to. So if you have a small context window, you are only allowed to repeat the sentence to one person. Now the person might misinterpret the sentence and the message might change as it's passed along. With a larger context window, you are allowed to pass the message to a few more people. So this ensures that the message remains more accurate as it is relayed from person to person. So this context window in prompt engineering works similarly. It controls how much of the surrounding text the AI model consider when generating a response. So a larger context window allows the model to take into account more information from input text, resulting in more accurate and contextually relevant responses. Now let's understand a simple Python code for context window. So in this code, we define a function that takes two arguments, a text and a context window size, right? Now, and it return a random substring of the specified length from the input text. Now, this function will first divide the input text into chunks of the specified length and then randomly select one of these chunks and return it. Now, this code then demonstrates how to use the function by calling it with a sample text and a context window size of 5. And this output is a randomly selected substring of length 5 from this input text. So next, let's understand what's temperature. Now this temperature in prompt engineering can be thought of as the randomness level or creativity factor that influences how varied the model's response will be. So this lower temperature results in more coherent and contextually relevant outputs, while higher temperatures leads to more diverse and potentially creative responses. So to understand this better, imagine you are a chef and you are following a recipe to make a meal. Now this temperature in prompt engineering can be thought of as a strictness of your adherence to the recipe. With a low temperature, you will follow the recipe closely using the exact ingredients and measurements listed. And the meal might not be the most exciting, but it will be familiar and well executed. But with a higher temperature, you might be more creative and can make substitutions using different ingredients or adjust the cooking methods, which can result in an innovative and unique dish. But it might also be a bit of a gamble. So in prompt engineering, the temperature parameter affects the level of creativity in the model's responses. Lower temperature results in more predictable and contextually relevant outputs, while higher temperature leads to more creative and diverse responses. So to understand this better, let's code temperature in Python. Now this code defines a function that takes two arguments, a text and a temperature level, and returns a response that depends on the specified temperature. Now this function will generate a random number between 0 and the specified temperature, and based on this random value, it returns either a predictable and contextually relevant response or a diverse and potentially creative response. Now this code then demonstrates how to use the function by calling it with an example text and temperature of 1.0. Now this output will be either a predictable and contextually relevant response or an unpredictable and potentially creative response depending on the randomly generated value. Thank you.